Good day, class. Today's lesson is all about expressions. Now, I'm not talking about excited and grumpy, like those kinds of expressions. We're talking about mathematical expressions today. So here's your learning goal for today's lesson. I can write a problem as an expression in which a letter variable is used to represent an unknown number. Now, in this learning goal, you see two words that are bolded. First, expression, and second, variable. So if you don't know what those two words mean, let's visit our next slide here. A variable is a symbol for a number we don't know yet. It is usually a letter like X or Y, but can be any letter of the alphabet. And in fact, it can be any letter of a Greek alphabet. It doesn't even have to be the English alphabet that we use for that. So a lot of times, we're going to be moving into algebra. And in algebra, we use letters to represent numbers that we don't know yet. So that's the definition of a variable. And then the second definition here is expression. And an expression is a sentence with a minimum of two numbers or variables and at least one math operation. So the four basic math operations are addition, subtraction, multiplication, and division. And so anytime you see a mathematical sentence that includes two numbers or a number and a letter that are separated by one of these operations, we're dealing with an expression. Now, I also just wanted to put this definition on here of an equation. We aren't going to do too much work with equations today, but it's probably worth knowing how equations are similar and different to expressions. So an equation uses the equal sign to show two things represent the same amount. So for example, 5 plus 2 equals 7. And if we have a look at the left side of this equation, we add up 5 and 2, and that equals 7. So on the left side of the equation, everything equals 7. And on the right side of the equation, everything equals 7. And so therefore, we put an equal sign between them to show that the left side is the same as the right side. Now that's different from an expression because an expression doesn't have an equal sign in it. So to help you understand the difference here, let's just pop up this next slide here. And I've just separated things into expressions and then equations. And so let's start over here with equations because that's probably what you're more familiar with in math. Anytime we do math or have done math in school, we are usually trying to figure out what something equals. So you can see here, I've got two numbers separated by an addition sign equals another number. Two numbers separated by a subtraction sign, or two numbers separated by a multiplication sign, or a division sign. Now I know you're probably looking at this symbol here, and you're saying, Mr. Mueller, that's not a division sign. Well, in algebra, there's a few different ways to show division. One way would be with your traditional division sign, and another way would be by using this backwards slash. So anytime you see this in algebra or in math, you know that we're also talking about division. But I also wanted to show you that it doesn't have to be two numbers over here. We could also use a number and a letter that are being added together, and this is still an equation. And so, yeah, if we continue down here, a number and a letter separated by subtraction. And here, this looks a little different. We just have a number and a letter right next to each other. And the reason that we do this is to show multiplication, is because the multiplication symbol is very easily confused with the letter X as well. And so mathematicians all around the world just agreed that whenever we're multiplying a number and a letter together, you don't have to put a multiplication sign between them. You just put the number and the letter together, and then we automatically know to multiply it. And then down here as well, 15 divided by z. So those are all equations, what different equations may look like. Whereas expressions, you'll notice they're all missing one thing. None of them have an equal sign. So these are all examples of expressions over here. And this is what today's lesson is all about. It's about mathematical expressions. So we're going to move forward to our next slide here, and I'm going to give you a sentence, and we are going to see if we can convert this sentence into a mathematical expression. So the first example here is write an expression for the total of 25 and t. And this would be an example of an addition style expression where we're just simply going to take the number 25 and we are going to add it to t. 25 plus t. And then we're done. We're done that example. We have created a mathematical expression because they haven't told us that this equals anything. All they've given us is a number and a letter and an operation to tie those two together. But I wanted to show you down here, this one looks like a very similar problem. It says write an expression for the total of t and 25. And the only difference here is that the t and the 25 are in a different order. But regardless of what order they give you, t plus 25, we can write an expression, t plus 25 here, and we have our answer. Now, I'll let you in on a little secret because a little bit later today, you're going to be working on IXL, and you'll see examples or questions in IXL that look exactly like this. Write an expression for the total of 25 and t. And if you write 25 plus t, you'll get it right. But if you write t plus 25, oops, I just realized I made a mistake here. This should be a 25. Oh boy. Now that looks like a Greek letter. There. Close enough for me. If you write t plus 25, you will also get that question right. So when you're dealing with addition expressions, order doesn't matter. It doesn't matter whether you put the number or the letter first. So that's just a helpful little life hack there that might get you through IXL a little quicker. On the next one here, though, we have write an expression for n minus 26. And so what that's going to look like when we write an expression, we're starting with a starting amount of n. That's some amount that we don't know the value of. And then we're minusing or subtracting 26 from that. 26. All right, but just like I did with our first example, I have gone and rearranged the order of the numbers in the second example on this page. So this one says write an expression for 26 minus n. So this one will start with our amount of 26, and from this we are going to subtract an unknown number, 26 minus n. Now, here's the thing with subtraction is that order actually matters here. And let's think of a concrete example. An example where we're using just two numbers. So let's say I give you $10, or you start with $10, and then we subtract $5 away from that. You're going to have $5 left over. But if we take those numbers and switch the order around, let's say you start with $5 and then we take $10 away from you, that's a problem. That's going to be us taking more money than you have to give. And so you can see with subtraction style problems, order does matter. So if you were to get this question, the top one here on IXL, you would for sure have to put n first, minus 26. All right. So moving on, we've now dealt with addition and subtraction style problems. Now let's have a look at an example of multiplication. We want to write an expression for the product of 7 and h. Now let's stop for a second. Product is just another word that mathematicians use to say the answer of when we multiply two numbers together. So let's write an expression where we are multiplying 7 and h together. Now, mathematicians all over the world have also agreed on this, that whenever we're multiplying a number and a letter together, it is the proper thing to do to write the number first and then the letter or the variable after it. And remember, with multiplication, we don't have to put a multiplication sign between the number and the letter. Otherwise, we might confuse that with an X. So if we do the second example here, again, it's the exact same question. I've just switched the order of h and 7 here. But because of that little thing that mathematicians all over the world agree on, we are still going to write it with the number first and the letter second. So anytime you are typing the product of a number and a letter, be sure to write the number first, please and thank you. Okay, and that brings us to our last style of problem, which is division. And grab my pen here again. This one's saying write an expression for 13 divided by y. So just like subtraction, order does matter for this. It's a different, if we have 2 chocolate bars and we want to divide that between 10 people, that's a lot different than if we have 10 chocolate bars, which we want to divide between 2 people. So order definitely matters here. So you have to pay attention as you're reading the problem. We are taking 13, which is my first number, and we are dividing it by y. So we will use this notation. So 13 divided by y would be one proper way to write that. A second proper way to write that would be using that other symbol that I showed you earlier in this slideshow, which is just a little backwards slash, 13 divided by y. And another proper way of writing that would be 13 divided by y using the division symbol. Okay, 13 divided by y. Now, when you're doing your IXL assignment, it doesn't allow you to enter it in as the fraction form. And the last time I checked, our keyboard doesn't have the divide symbol either. So that leaves us with one option. When you're typing an answer like this into IXL, you're just going to want to enter in 13, and then you find the backslash, which shares the same key as the question mark. So that may help you find that button. And then you would type in a y for that. Okay, but yeah, let's have a look at this last example. Write an expression for your y, or sorry, for y divided by 13. So there's my y, and we're going to divide that by 13. All right, so we've had a look at all different types of questions using all 4 of the operations. So that is where the lesson ends, but I do want to give you just a helpful little life hack here. And in fact, you may want to pause the video right now and have this screen handy, because there's a lot of times students really struggle to figure out, okay, is this question asking me to add or subtract or multiply or divide? And there's some really good keywords that you can find within the question that would tell you whether it's addition, subtraction, multiplication, or division. So for addition style problems, you might see words like gain or sum or add or more. John has 5 more than his friend, or the amount increased, or find the total of this and this. So those are all really good keywords to just help you realize that you're supposed to be adding numbers together. And then subtraction, we would have kind of the opposites of those words for addition. We would have reduce, difference, subtract, fewer, less, decreased. So those will be really helpful for you to recognize those words. For multiplication, there's a fewer number of words that are kind of that point you in the right direction, but you'll often see like multiply or find the product, or there's 8 groups of 7, right? And anytime you see terminology like that, you know you're going to be multiplying numbers together. And the last one here, division. Yeah, keywords to look for in that question would be divide, or find the quotient, or this amount was shared evenly or split evenly between a group of friends. So those are all just words that would help you out. So like I said, maybe pause the video at this point here so you can see these keywords here. And then at this point, you can head on over to IXL and complete skill R1 at the grade 5 level. I hope this video will help. Thanks for watching. We'll see you tomorrow.